So we'll begin our review of the JavaScript language by starting out learning about the types and some of the basic workings of them, just to make sure we're fully up to speed on them. JavaScript has a few basic or simple types, which are number, boolean, and string, and then some complex types, which are object, array, and function. Array and function are actually objects themselves, but have some additional features in the language to make them easier to use and more powerful. For this lesson, we're going to be doing most of our things in the Node REPL, so we'll start that up right now and we'll take a look at it. There are actually two other values in Node, two other types in Node, which are called null and undefined. Undefined is actually just a special value which says that this variable or this thing hasn't had a value set or doesn't exist yet. So here I declared a variable called x. The return value of that expression is undefined, and x, since I haven't set a value, it itself is also undefined. I can choose to explicitly set a null value on x, which is now a specific value. X is now no longer undefined. It is actually just an assertion that the value there is empty or null or not a sort of valid value. If I were to declare x as an object, and then I were to ask for the value of some invalid property on x, you would see that I would also get undefined. One very useful thing I can do in JavaScript to learn what type something is, whether a variable, an object, or some specific value or something, is to use the type of operator. And I can ask, what type is this thing? And it'll tell me that that's an object. If I declare a function here, if I say, let's function like that, you'll see I get that the type of that is a function. Or if I do type of hello, you'll see that that's a string. So that's the absolute basics of types. Let's go on and start looking at numbers. Numbers in JavaScript are a little interesting in that they're represented as 64-bit double precision floating point numbers. For most of the things we do day to day in JavaScript, this won't be an issue. For integers less than 53 bits, 2 to the 53, you'll find that they work exactly as you'd expect. You can declare large integers and you'll get back large valued values. They're great. I can say var x equals that. I can say x star equals that. And then you'll see that it all works perfectly fine, as you would expect when working with integer values. One of the interesting things about the floating point type, though, is for certain values, irrational values, or integers larger than 2 to the 53 bits, it actually becomes an approximation. And even for certain floating point values, it becomes an approximation. So here, if I add 0.1 and 0.2, you'll actually see it's not 0.3, it's this 3000004. And similarly, when I'm trying to do comparisons, I'm trying to do mathematical operations. If I do 1 minus 0.3 plus 0.7 or plus 0.1, that's let's say, is that equal to 0.8? We'll see, actually, no, that's not. And again, that's because of this sort of weird approximations and everything you see with these floating point numbers. So for integer operations, if I'm using pure integers less than 2 to the 53 bits, it will work exactly as I expect. If I am doing floating point operations and then I'm trying to do comparisons on that, it is not going to work quite as intuitively as you might think it would. And for cases like that, you will want to sort of look at strategies of saying, I want to see if these two numbers are equal. So maybe what I wanted to do is subtract one from the other and see if the delta, the difference between these two numbers, is a certain very, very small value or less, in which case I can assert they're probably true. One of the other interesting things about double precision floating point numbers as my numbers is if I divide things, you'll see actually they just immediately go to floating point. It's not like some languages where integer division produces an integer. Since numbers are all floating point numbers, if I divide two integers, the result will actually be a decimal number sometimes. So you do want to be careful about that for the times when you are looking for integer values. In those cases, you can actually use the math.ceiling function like this, like 10/3, or math.floor like that. You can use these values to force them back to sort of integer values. So that's the basics of the numbers. JavaScript is a little bit different from other languages in that if you divide something by 0, you don't throw an exception or you don't, crash or kill your program. You actually get the number infinity. Or if I divide a negative number by 0, I get the value negative infinity. Your program actually continues to work fine, and infinity and negative infinity are great values. So if I have x equals 10 var y equals 0, and I say x slash y equals infinity like this, you'll see it actually is true. So infinity is a value I can test against and check for in my programs. So it's a little bit different. I'm used to languages, if you divide by 0, just saying, dude, you totally can't do that, and, blowing up in my face. JavaScript has a couple of other cool functions called parseInt and parseFloat. And so parseInt, I give it a string like that, and it actually returns the integer. You'll see here that I returned a huge value, so it actually prints it in E notation for me here if I want to do it for something a little more reasonable. Like that, it works perfectly fine. ParseFloat, parseInt, if I give it a floating point number, like that, will actually just return the integer portion of it, whereas parseFloat, 234, 234, 523, like that, will actually return the full floating point number. What happens if I give an integer the string banana? It returns a special value again, like infinity, called not a number, N-A-N. And the way I can test for a value, same thing with parseFloat. So parseFloat, blah, 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 returns not a number. If I want to test to see if something is this special not a number value, I will use a function for that. So I'll say var x equals cat. I can say parseFloat x equal, what I want to do is not a number, like that. And you'll see that's true. Whereas I can say is not a number parseInt 10. And you'll see it's false because that is actually a valid number. So the infinity, the negative infinity, and the not a number are special values in JavaScript. And there is actually a very helpful function which will tell us if it's a valid number or not one of these three special values, and that's is finite. And I can do is finite for an int. I can do is finite for a float. And I can say is finite not a number, and it'll return false. So that's the basics of numbers and sort of types in JavaScript. I will very quickly go over Booleans right now because they're not particularly challenging or require any time. Booleans can be true and they can be false, and that's pretty much all there is to it. There is a function here called Boolean which lets you convert something, but honestly you'll never need to use this because the language will, when it needs a Boolean, will convert things to and from Booleans perfectly automatically, and you won't even need to do it yourself. So when it is converting things to Booleans, the basic rules are false, 0, empty strings, not a number, null, and undefined are all false. These all return the value false when the language converts things for us. All other values become true. So that's basically how JavaScript does conversions. And yeah, that's really the basics of working with the Boolean type. It's pretty intuitive and something I'm sure you've seen many, many times before. Okay, so that's the basics of numbers and Booleans and some quick little type operators. Let's go ahead now and take a look at strings.